Okay, thank you. Let's see what happens here. There we go. Before I start, I would like to acknowledge my colleague and team member, Paul McDonnell, who has contributed greatly to this talk, but also to a lot of the work that lies behind this. Okay, so barriers to entry and why implementing new technology is challenging. The mining industry is often accused of being traditional and slow on the uptake of new technologies. I do kind of understand this, but I also do not agree. I would actually argue that we often are at the forefront of technological development in supporting research and testing all sorts of new technologies. However, to actually implement something into our existing workflows, that is a challenge. And it can be extremely slow, but for good reasons. I mean, we're not doing it because we don't want to. So this will not be a technical talk at all. Instead, I will try to give you some of the insights into what kind of challenges we face, and many of which have nothing to do with technology. I want to do this because I think that one of the main barriers to entry in terms of adopting new technology is the lack of understanding of the perspectives of the different players in this game. And by that, I mean industry or end users, academia, technology developers, and service providers. And if you want to solve a specific problem, you have to understand all of the related challenges that comes into play when you try to change something. So here is the perspective of a potential end user in the mining industry. And in a fairly big company like Boliden, nothing happens in isolation. So it's important to have some sort of idea of what the complicated organization might look like. But instead now of looking at the company from top down, I will turn things on its head a little bit and start with the department that likely would be the first one you would get in contact with if you're in geoscience-related technology development or academia. And that is the Exploration R&D department, which I'm managing. This is a small department with specialist competence within a few different disciplines: structural geology, quaternary geology, data management, and geochemistry. And our roles are research and research coordination, and to carry out internal development projects, and also to support the organization as in-house consultants. We're part of the staff function that's called exploration, which is headed by the exploration director. And in addition to our department, there are 4 more departments under exploration, and these are near mine exploration, field exploration, exploration geophysics, and geodata. And as you can see, there are also several sections organized under these departments. There's a lot of people. We're currently 115 permanent employees in 6 offices and 3 countries, and we're around 20 different nationalities. Exploration is one of several staff functions that report to President Business Area Mines. And apart from us, there are also business development, finance and commercial, HR and safety, sustainability, and technology. Also belonging to Business Area Mines are, of course, our mines. We have 5 mine areas, and these are Tara in Ireland, Kevitsa in Finland, Garpenberg, Boliden area, and Aitik in Sweden. And then you should know that Boliden area contains 3 mines: Kankberg, Renström, and Kristineberg. Zooming out even more, you can see that Business Area Mines is one of 2 business areas, where the other one is Business Area Smelters. So in total, we have 7 mines and 5 smelters, and somewhere around 6,000 employees. And those of you who've been following the news lately realize that these numbers might change during the year. But for now, they're fairly accurate. We will have a quick look now at the Exploration R&D strategy and a brief glance at some of the projects that we are involved in. So we have 3 main focus areas: data acquisition, modeling and visualization, and mineral systems knowledge. And these are interlinked, and in most projects there are aspects of all three represented in some way. We also work with development in terms of trying to find improvements to the way we work, but also train and develop the staff in our exploration teams. Looking at a few examples of projects that we've been engaged in, we can start in the mineral systems knowledge area, focus area. And this is where we look at the actual geological questions. And we have had several PhDs co-funded or fully funded by Boliden on various projects. The example here is David Ray and Carroll's PhD on Mountain North, which was a collaboration with ICRAG and University College Dublin. Modeling and visualization includes any type of modeling, from 3D modeling to modeling of geochemistry or other data or information in data space. And AI will, of course, be a component here. In here, we have our digital geology R&D program, in which we're investigating new ways to visualize and interact with geoscientific information. And here we're looking at how we can scan mine faces or outcrops to provide 3D information that is good enough for use for certain mapping purposes. We also look at software that can be used for visualization, as well as geological mapping and remote real-time collaboration in virtual reality or across other platforms. And this will have benefit for safety, will save time, and in some cases, it will probably even increase the extent and quality of mapping. We have massive amounts of legacy data going back more than 100 years. And currently we're working on digitizing all of the relevant information in our archives. And the idea is to make it easily accessible via free text search and also spatial search. But with all this unstructured data in digital form, we will also be able to make use of natural language processing for information mining. In the data acquisition focus area, we look at new ways of acquiring data, both in the field and mine environment, and also in drill core. So in the Future Logging Assistant R&D program, we're looking at different sensor technologies and possible workflows for how to make use of them. And the focus here, of course, is on drill core. This can be anything from improving normal white light or UV light photography to different scanners collecting geochemical and mineralogical information, as you can see here on the right. Within this program, we're also working on AI solutions to support the geologists in the drill core logging tasks. And working with this, we have 2 Boliden-funded PhD students at Luleå University of Technology, 1 geologist and 1 data scientist working together. So now you've got a short glimpse of some of the stuff we're working on and some of the technologies we're looking at. And this is far from all. But we'll now turn to some of the challenges that we, for some reason, seem to face in most of these projects. The pace of technology development is much higher than the pace that we can achieve in testing, evaluating, and implementing new solutions in the exploration workflow. This is partly due to the lack of time that we can dedicate in our exploration teams, which are our end users. But the current way of working will also always have to be conducted in parallel through any evaluation and implementation process. And this adds a lot of stress and resource need to the organization. It's also a fact that many of our processes that involve mapping, drilling, sampling, etc., they practically take months or even years to perform. And this also means that it can take months or even years to fully evaluate the impact of a new tool. So in other words, we're constantly struggle to keep up, even if we want to. And in order to get anything done, we have to pick a few technologies that we believe in and focus on them, as other solutions will have to wait. But how to confidently pick the right ones, that's, of course, a real challenge. The people aspect is probably one of the most challenging in all of this. And I will share a few observations here from experience and also a little bit how we deal with them. We often see early interest from many when we try to introduce a new piece of technology, because of course it's exciting. However, few follow through to become early adopters. And the reasons for this can be many, of course, but one example is that learning to understand and use new technology to the point where you actually start benefiting from it. That takes time and effort, and it adds to the daily work. And unfortunately, the daily work is a full-time job. However, among the early group of interested, there are hopefully a few potential early adopters. And these can be people who are just keen to develop and learn new things, or maybe love technology. Could also be someone who have a current problem that this technology might be able to solve. We want to try to identify these people early, because they can play a key role as ambassadors for this technology during the investigation and implementation phase. So going forward, we focus on supporting these ambassadors in their efforts to make full use of the technology. When the ambassadors are up and running and start to feel the benefits of their efforts, others will show interest again. Because now that they can see proof of how much benefit there is to this new technology, they will one by one start to make the effort it takes themselves. But this process can take a very long time. And when we finally get to the stage where we've managed an implementation, well, then new technologies are already out there and people are wondering why we haven't adopted them yet. So we're always several steps behind. And we're most likely always going to be. At the moment, there's a hype around AI and technologies that provide automated data collection. And there are solutions out there thrown at us from right, left, and center. Everyone, of course, has the best solution for us. And somehow we have to look at multiple solutions at the same time. And this is not always easy. Many tech companies try to sell a very well-polished product that normally promises real-time data processing and interpretation using AI. It looks very good on the surface. And what we're told, of course, is also very promising. But after testing it for a while and digging into the details, it often turns out that the results are not really provided in real time at all. At least not according to our definition of real time. And in some cases, the AI turns out to be an army of minions with Excel sheets, and perhaps even in a different time zone. The company says, of course, that they're working on their AI capabilities, but they're not quite there yet. So what they're doing, in essence, is selling a vision. And this is not great for building trust, not in the company and not in their product. It also takes a lot of time from us to go through the process of discovering what the limitations are. And since we're constantly looking at several different technologies in parallel, this is time that we do not have. If we were told about these minions from the start, it would save us time, it would build trust, and we would probably find a way to work with this technology anyway. We're also repeatedly approached by new software companies and data scientists who brag about their computing power and powerful AI solutions. And they want us to tell them where our bottlenecks are, because they can, of course, fix them for us. And they always, for some reason, seem very confident. The problem is that since they often come from the data science or engineering space, they do not always understand geoscience and why we do things the way we do. And I mean, we normally have good reasons. And it's very common that they underestimate the complexity of geology and overestimate the capabilities of their AI solution. Our data is what it is, and it will limit what is possible. If you don't understand the limitations of your data, you will not be able to generate meaningful results, no matter what methods you use. And just because you're using measured values on a machine to interrogate them, it doesn't mean that your results are unbiased. So for us to be comfortable, we need to gain trust both in the service provider and the results produced. And the best route to this is to get to know the developers and also to hear them honestly talk about the limitations of their products. Because if they tell us we cannot do that, we will immediately listen more closely when they say what they can do. Salespeople who promise too much, they often come in the way of potential partnerships. So this leads us to what we call barriers to entry, which are obstacles that might hinder or stop us from implementing a solution to a business challenge. And the challenges I've just mentioned play a big role in this, of course, but there is a myriad of other things that also can throw a spanner in the works. We like to look at this as a big jigsaw puzzle, where all the pieces have to fit together. If they don't, we fail. One of the most stubborn pieces is probably understanding, and this can refer to many things. It can, for example, refer to the understanding of the geological problem or technical challenge that we're trying to solve, but also to the understanding of the different perspectives of the end user and the tech developer or academia, which is important to be able to succeed with an implementation. Now we'll touch on a few more examples from this puzzle. So from a customer's perspective, there are many different solutions, each one addressing some of the challenges we have. We need to investigate each technology fairly and objectively, but this is not always easy when vendor business models can be convoluted and sometimes leaving the important questions wide open. Like, how much does it actually cost to implement? Are future costs predictable and easy to budget for? What about the hardware? Who owns it? These are questions we don't always get answers to. We have to drag them out of the vendors. Within the interlinked workflows of an exploration and mining company, fitting a new tool can sometimes be a real headache, and this is not helped if the new tool adds extra work or time. So is your real time the same as mine? If real time turns out to mean 48 hours and not 2 minutes, we might have to change the order of when we do things in our workflow. And this may be a major challenge. In any project, plans to manage the data needs to be in place early. We need to understand formats, rates of creation, frequency, tactics for purging data, etc., etc. And data quantities that are several orders of magnitude larger than we are used to, that's a challenge in itself. If we look at suitability and solvable geological challenges, the fact is that a geological challenge may not be solvable with a certain technology. So is the solution fit for purpose? The time we have to spend investigating suitability can be a barrier in itself, especially since we always are short on resources and always are addressing several different challenges in parallel. Does the solution create quality or consistency? Does it save time or add something new to the knowledge creation? In other words, does it create enough impact to be worth the effort? This is not always the case. Geology is complex, and it requires deep knowledge to first understand a challenge before trying to fix it. And when service providers approach you with their new and really cool technologies, there's always a risk that you start to look for ways to fit that into your workflows, instead of doing the opposite, which would be to define the problem that really needs to be solved and then find a technology that can address it. So if we look at design and ergonomics and scalability, this is something that's often overlooked. But in the industrial context, all tools, technologies, and innovations have to be safe and ergonomic, and they have to be practical. And this is certainly not always the case. They often also have to be usable at an industrial site or at industrial rates of throughput. And here we also need to consider how easy or costly it is to increase or decrease throughput as seasonal demands fluctuate. To finish off, we come back to people and change management. And there are many different models of change, but finding the one that fits the culture and climate or the personality and mood will depend on when and where the disruptive technology is being introduced. And there is no one size fits all. Calming expectations and managing the fallout from inflated promises is a real challenge. So you don't really want to find yourself in that position, because poorly managed expectations in one project will affect implementation of other solutions in the future. So I will wrap up with some insights that we bring with us going forward. We will look at both mining companies and technology vendors here. We can all improve. At the mining companies, the foundations need to be load-bearing. The digital transformation needs to be advanced. And with this, I mean that we need to have the know-how in place as well as the IT infrastructure to be able to implement new solutions in the future. And this is not always the case today. Enhanced cross-departmental understanding of combined challenges, that is breaking down silos. We still do too much in parallel, reinventing the wheel, without making enough use of each other's competencies and solutions internally in the company, but also maybe between companies. Compatible models of change need to be defined and tested. In order to be efficient in implementing new technology, we need to understand what works in a certain culture or in a certain part of the company. And we need to have at least some sort of systematic approach, not shooting from the hip every time. Clear understanding of and measurement of cost benefit. Well, this means that we need to have a fairly detailed understanding of all the costs related to our current workflows as well, so that we objectively can measure the actual cost of a new solution. If this solution removes several steps or costs, you might find that it pays for itself. In another scenario, it might not remove any costs or even make things more efficient, but the added knowledge or information is so valuable that it's worth it anyway. Dynamic workflow adaptation. Many of our workflows are quite rigid. And they are so because they're part of a constantly producing value chain, which means that changes can have both positive and negative effects downstream. So we have to be aware of that and be careful. But if we can find ways to be a bit more dynamic, this would help technology implementation as well. Technology vendors need to recognize that changes are not quick and straightforward, and preferably also why. Be aware that multiple technology evaluations are occurring in parallel, competing for time. So even if we're super interested, we very rarely can drop everything for a meeting next week. Understand that the customer may lack expertise in your technology. And when you don't fully understand the technology, it's harder to trust, and it will take longer to get to an implementation. Recognize also that fundamentals, such as, for example, cost and practicality of use, can put customers off. If the solution is not practical, or the cost is way too high or difficult to predict, interest may fade early. And last but not least, to be open about what you cannot do is as important as what you can do, because this will improve trust and save a lot of time for all parties. So in summary, the takeaways from me, I hope, is that building trust is important and patience will always be needed. Thanks for listening.